Welcome to the Working with Graphics Layer and Reports Pro SDK session. My name is Uma Harano and I'm a member of the Pro SDK team. Here is a session overview. We will begin with graphic layers. We will learn what they are, how to create graphic layers, graphic element management, and how to programmatically select and group graphic elements. The second part of the session will cover the new Reports Pro public API. We learn about the report data source, how to programmatically create reports, modify reports, and export reports. Graphic layers is a type of layer in ArcGIS Pro. It is a container that holds graphic elements. These graphic elements can be points, lines, polygons, text elements, and even pictures such as JPEG and PNG, as seen on the images in the slide. Graphic elements can be used to visualize a map without the need for adding features. Currently, graphic layers and elements are only supported in a 2D map. A useful feature of the graphics layer and graphic elements is that they are persisted. What this means is that you can save a graphics layer as a layer file or a layer package. This makes it portable. Also, graphic elements are persisted as feature collections in a shared web map. Additionally, maps that include graphic layers can be added to a layout. This is very useful for printing and exporting graphic layers. The Pro SDK exposes a property called the target graphics layer on the map object. This property defines the current graphic layer that is the target for Pro's interactive graphic element creation tools. This SDK property can also be used to change the current active graphics layer. The code snippet at the bottom of this slide illustrates this. I first find the specific graphics layer in the map using the find layer method. I then set the target graphics layer property on this layer. This will allow Pro's interactive tools to create elements in this layer. To create a graphics layer programmatically, use the templated flavor of the create layer overload available in the layer factory class. The templated type is set to graphics layer. This method requires a graphics layer creation params object as a parameter. This is where you specify things like the name you want to use for your layer. Notice a code snippet at the bottom of this slide. I first create a graphics layer creation params object using the constructor, and I set the name property to the name I want to use for my new layer. I then call the templated flavor of the create layer method, and I set the templated type to the graphics layer. I pass in the graphics layer creation params object as a parameter and the map to which I want to create my layer. This method will return a graphics layer object, and it will also automatically add the newly created layer to the map. Here in the code snippet, I've also shown you how you can remove a graphics layer. I'm accessing the graphics layer I want to remove using the find layer method. I'm filtering for the type graphics layer. I pass in a string for the name of the layer. This will return a graphics layer back. Then you simply call the remove layer method on the map object and pass in the layers you want to remove. In this demo coming up, I'm going to show you how you can create a graphics layer and how you can change the target graphics layer for the active map. I have an ArcGIS Pro project open over here. The active map that you're seeing has a couple of graphic layers. First, I have the original graphic layer at the top of the TOC, and then notice this graphics layer within the group layer. I've also created a collection of different graphic elements. These are balloon callout text labels to label the state names. I have a picture graphic and a few more text elements. And then notice this red freeform line that I've used to highlight the specific states. All these graphic elements belong in the original graphics layer. So if I toggle the visibility of this graphics layer, notice that my elements are no longer seen. So the first thing I want to show you is how to create a graphics layer. So within this tab over here, I've created the Create Graphics Layer button. I've done that using a Pro add-in. Now let us step through the code behind this button. Here is Visual Studio with my breakpoint being hit. The first thing I'm doing here is I'm getting my map object my map view.active.map. I'm saving that in the map property. The next thing is I'm creating a graphic layer creation params object using the constructor. I'm setting the name property to the name that I want to use for the graphics layer I'm creating. Next, within the context of the queued task, I'm calling the createLayer method on the layer factory class. This is a templated flavor of the overload. Notice that I'm specifying the templated type to be graphics layer. The parameters I'm passing are the graphic layer creation params object that I just created and the map that will contain my new graphics layer. This method is going to return a graphics layer object. This graphics layer will be automatically added to the active map. So now let us look at that in Pro. I'm going to hit continue. Notice the first graphic layer that has been created by our custom code added to the top of the map. Next, I want to show you how to access and change the target graphics layer property. This is the graphics tab created by Pro. So within this tab, you have various graphic element creation tools, some selection tools. Here are the controls that you can use to change the symbology of graphic elements. And here you can group your graphic elements, order them, etc. Way on the left over here, notice this drop-down combo box. This is currently set to the target graphics layer for this map. So right now, this combo box is now set to the original graphics layer. So if I use a point graphic creation tool and create a new point element, it's created to the original graphic layer. So to test that, I'm going to turn the visibility of the original graphics layer off. Notice how my new point element is gone. So let's get that back. So right next to this drop down, I've created another button through my add-in called the Change Target Graphics Layer button. So now let's step through the code behind this button. So here in Visual Studio, I'm again getting the map object. Next, I am getting the collection of all the graphics layer in my current map and I'm storing it into this list property. As you may recall, there are 3 graphics layer in the map. So the next thing I'm doing here is I am getting the target graphics layer on the map and setting it to this property. So I want to change the target graphic layer. So in the next 2 lines, that's what I'm doing. I'm finding another graphics layer in the map. I'm finding the index of the current graphics layer over here. And then I set the index property to the next item in the collection. So now I'll have a new graphics layer. So here in this line, I am setting the map's target graphics layer property and I'm setting it to this new graphics layer. So now let us look at that in Pro. I'm going to hit continue. And here back in Pro, notice that this drop down has now changed to my graphics layer in a group. So let's test that. I'm going to get the rectangle tool and then I'm going to create a big rectangle over here. So now if I toggle the visibility of this graphics layer in the group, notice that my rectangle has now disappeared. So this was a quick demo to show you how you can create a graphics layer and how you can access and change the target graphics layer property. Now let's go back to the slides to learn about graphic elements. Graphic layers are containers for the graphic elements. The graphic element object derives from the ArcGIS desktop layout element class. So a layout element and a graphic element are the same and have the same properties and methods. Graphic elements in Pro can be points, lines, polygons, linear or curved text, and images such as PNGs, JPEGs. In a given map, each graphic element has a unique name. This is important to remember and helps to access graphic elements. Cumulatively, graphic elements in a map cannot contain more than 10 megabytes of elements or 4,000 graphic elements. The graphic element class in the Pro API is a managed wrapper class for the sim graphic object. So a graphic element contains a sim graphic. The sim graphic is the sim representation of graphic element. Sim refers to Pro's cartographic information model. The sim graphic provides finer grained properties for the graphic element that is not available in the graphic element class. For example, using the sim graphic, you can access the geometry and the symbology of the graphic element. The schematic in this slide walks you through the process of accessing the sim graphic from the graphic element. Use the getGraphic method on the graphic element to access the sim graphic. The sim graphic obtained is the base class. The various derived types of sim graphic class are sim point graphic, line graphic, sim polygon graphic, sim text graphic, etc. Using the sim graphic, you'll be able to access the geometry and the symbology of the graphic element. To add an element to a graphics layer programmatically, use the add element method on the graphics layer. There are various overloads available for the add element method. These methods allow you to use the geometry, symbology, or the sim graphic directly to create graphic elements. I have listed the various overloads at the bottom of the slide. We will be looking at a few of these in the slides coming up and in the demo. To add graphic elements programmatically, there are two basic patterns. I've illustrated both these patterns in the slide. In the first pattern here, I'm passing a geometry, in this case a point geometry, to the add element method. The symbology used to draw the point is an optional parameter. Notice here on this line of code, I am passing in my point geometry and the symbology to the add element method. This returns a graphic element object. Now let us look at this pattern number 2. In this example, I create a sim point graphic object. Inside the constructor for the sim point graphic, I specify the geometry using the location property. I specify the symbol to use to draw the point using the symbol property. And then over here, I'm calling the add element overload method and passing in the sim graphic that I just created. And in this case also, a graphic element object is returned. Existing graphic elements in a map can be modified programmatically using the Pro SDK. The two aspects of a graphic element that can be modified are its geometry and the symbology. For example, the graphic text element can be misplaced on a map. You can move the location using the Pro SDK. Additionally, you can change the symbology of graphic elements also. This slide illustrates the 3 steps used to modify existing elements. First, retrieve the sim representation of the graphic element using the getGraphic method. The sim graphic allows you to access the element's finer grained properties such as the geometry and the symbology. Next, make changes to the sim graphic. Here in this example, notice how I'm changing the point graphics location to a new location. I'm calling the geometry engine's move method to move the point by a certain distance. I'm also changing the point graphics symbol property and I'm setting it to a new symbol using the construct point symbol method on the symbol factory class. Finally, after I have made all these changes to the sim point graphic object, I apply these changes back to the graphic element using the setGraphic method. I'll be demonstrating this in the demo coming up. When a graphic element or a group element is selected, a bounding box is displayed on the view and grab handles are also shown. To select elements programmatically, use the select element method and pass in a single element, or use the select elements method and pass in a collection of elements. Similarly, you can unselect elements using the unselect element or the unselect elements methods. I have 2 code examples shown here on this slide. Here on the left, I select all elements with a name beginning with text. I call the getElements as a flattened list method on the graphics layer. This gives me all the elements in a flattened format without preserving the nesting of elements and group elements. I then use a link query to query for elements with the name starting with text. I then call the select element method and pass in the retrieved elements collection. Here in the code snippet on the right, I'm using a sketch geometry to select graphic elements in a map view. I'm calling the select element method on the map view. I pass in the sketch geometry within which I want to select all the graphic elements. While selecting group elements and their contained children, there is a nuance with the selection. You can either select the group element or the children. You cannot select both. This is seen on the screenshot over here on the top right. A group parent is selected over here, and on the right, the children are selected. Here on the bottom of the slide, there's a code snippet that illustrates this. I first get the group elements in a graphic layer. I then make a list to hold this group element. I now add the children of the group elements to this list using the elements property of the group element. This list now holds my group element and its children. Now I select elements using the select element method on the graphics layer. I pass in my graphic element collection that contains the group element and its children. In this case, Pro will only select the group elements. Graphic elements can be grouped and ungrouped using the Pro SDK. Use the group elements method to group elements and use the ungroup elements method to ungroup the elements. When you group elements, you get a new group element object. This group element will contain the children elements in the group. Access the children of the group element using the elements property. Access the child element's parent using the getParent method. This will return the group element. Elements can be grouped in any number of hierarchies, groups contained within groups, etc. This slide has a code snippet that shows grouping elements, accessing the child elements in the group, and accessing the parent of the child element using the getParent method. I will demonstrate this in the demo coming up. Z order of a graphic element controls the order of display of elements. The Z order runs from 0 to n-1, n being the total number of elements in a container. An element with the order 0 draws first, and the n-1 element draws last. To change the Z order of an element, use the bring forward or the send backward methods. An important thing to remember here is that the Z order of an element can only be changed in the elements container. This is shown by the image on this slide. There are two group elements on this image. Notice how the Z order is set within each group element container. To move an element to the top of the Z order, use the bring to front method. To move the element to the bottom of the Z order, use the send to back method. Can bring forward and can send backward methods can be used to check whether an element's Z order can be changed. This slide has a detailed code snippet for ordering of graphic elements. Let us say you want to change the order of a couple of graphic elements so that they draw on top of the other elements. It could be a text graphic that you want to display over a polygon graphic, for example. The first thing I do in this code is to retrieve these elements using the getSelectedElements method on the graphics layer. I then check if these elements can be brought forward using the canBringForward method, and I pass in the collection of the selected elements. Then over here, I use the bringForward method and I pass in the elements. Similarly, in the code block below, I illustrate how you can send elements backward using the send backward method. The last line over here, I show you how you can get the Z order of an element using the getZOrder method. This would be helpful for debug purposes. In the second demo for the graphics layer, we're going to see how you can create graphic elements, how to select elements, group them, and finally we will see how you can modify graphic elements. I have the same project open over here. This map has a couple of graphics layers, as you can see in the TOC, and various graphic elements to visualize. I have a custom tab, Graphic Layer Demo 2 tab, hosting a collection of buttons and tools. I'm going to go through each of these buttons for this demonstration from left to right. Let us first create a graphic element using a geometry and symbol using this button. So I'm going to click on this button, and here in Visual Studio, my breakpoint has been hit. I'm first accessing the graphics layer using the target graphics layer property. For the purpose of this demo, I want to create a green point symbol in the center of the map view. So over here, I am accessing the map view's full extent, and I'm storing it in this envelope variable extent. The next, I'm finding the center of this extent. This is the location where I would be placing my graphic element. Within the context of the queue task, I am first creating a green point symbol using the symbol factory's construct point symbol method. Next, I am calling the add element method on the graphics layer. I'm passing in the location, which is the center point of the map, and the green point symbol that I just created. This is going to return a graphic element object. So now let's hit continue and see the result in Pro. Here is my point graphic created at the center of the map. Okay, so I'm going to clean this graphic element up, and next let's use this sim graphics tool to create a graphic element using a sim graphic. So I'm going to activate this tool, and I'm going to sketch a rectangle on the map view. Here is my map tool, as you can see, and my breakpoint is hit in the onSketch complete callback of the tool. The first thing I'm going to do is get the sketch geometry and save it in this property for a polygon. And within the context of the queue task, I'm making a polygon symbol using the construct polygon symbol method on the symbol factory. And then I'm creating a sim polygon graphic object using the constructor. I'm setting the symbol property to the polygon symbol that I just created, and the polygon property to the rectangle that I sketched on the map view. Here in this next line, I'm calling the add element method on the graphics layer, and I'm passing in the sim polygon graphic that I just created. This returns the graphic element object. So one thing I want to show you here is when I use Visual Studio to access the properties behind the graphic element, notice that you have no symbol or geometry exposed by the graphic element. So next, here I call the get graphic method on the graphic element. So this returns a sim representation of the polygon graphic. So now if I hover over this in IntelliSense, you can see that you now have access to the polygon graphic and the symbol properties. So now let's look at the result in Pro, and here is my green rectangle that I just created. It's a graphic element. So again, let's go ahead and clean this up, and then now I want to show you how you can programmatically select text elements from this map. As you can see, there are various text elements that I've created on this map. There are a couple over here, and then there are these state name label graphics and another text graphic element over here. So we're going to select all that programmatically. I'm going to call this, I'm going to click the select text element button. Here in the code behind, the first thing I'm going to do is I am calling the get elements as a flattened list method on the graphics layer. This returns a collection of all the graphic elements in my map. And then I'm using a simple link query to only filter for my text graphic elements. If the name of the graphic element contains the word text, that will be filtered and saved to this list of graphic elements. So over here now I'm calling the select elements method on the graphics layer, and I'm passing in my collection of text elements. Now let us look at this in Pro, and you will notice that only the text elements have a selection grab handles around it. Okay, so let's clear the selection. Now I want to show you how you can group elements programmatically. Here I have a group elements tool. So I'm going to activate this tool, and for this demo I'm going to select these 3 graphic elements using my tool. So here is the on sketch complete callback. Using the rectangle that I sketched, I am storing that rectangle as my selection polygon. And then I'm calling the select elements method on the map view. I'm passing in my selection polygon that I just sketched on the map view. This returns a collection of graphic elements that are contained within that selection polygon. So next, I am calling the group elements method on the graphics layer, and I'm passing in the collection of elements that I want to group. This returns a group element object. So now let us look at it in Pro. Notice that the 3 elements are now grouped, and this is the group element. Okay, so now since this group element is selected, I want to show you how I can ungroup them. So here is my ungroup element button. Let's look at the code behind. So again, I'm getting all the selected elements on the map. Here in this case, it was that one group element. So I'm going to construct a list that holds all the group elements. In our case, it's just one, but it could have been more. So I create an empty list, and then I iterate through this list, and if it's a group element, it gets added to my elements to ungroup property. So here in this last line of code, I'm calling the ungroup elements method on the graphics layer, and I'm passing in my collection of elements that I want to ungroup. So now when we look at the result back in Pro, notice that my group element is now ungrouped as indicated by the selection handles. Okay, so now let's clear the selection, and then I want to show you my final workflow. Notice this visualization here for the states along the Pacific coast. I can improve this visualization. The callback label colors blend in with the state background. So I can change the callout labels so that they stand out, and also notice that the labels are hiding the features underneath, like some of the cities and most of the state is hidden by these callout labels. So these are the 2 aspects of these text labels that I want to change. So I'm going to accomplish that by my update graphic button. So I'm going to click on this button, and let's step through this code. So the first thing I'm going to do is on the graphics layer, I'm going to get all the elements, all the graphic elements, and then I'm going to use a link query to filter out only my state text labels. So for all the elements that are named state text, those are the ones that I'm going to store in this graphic elements collection. Next, I'm going to iterate through these graphic elements, and I'm going to access each one of their sim graphics behind the graphic element. So that's what's happening over here. For each graphic element, I'm calling the getGraphic method, and I'm casting it as a sim text graphic. So now that I have the sim text graphic, I want to change 2 things. I want to change the symbol to make the color stand out, which is the first thing I'm doing over here. And then I want to move it. So to change the text color, I'm first accessing the text symbol in my sim text graphic. And then that's what's happening here on line 37. And then within the sim text symbol, I'm accessing the balloon callouts, and I'm getting the color, the background color layer of the callout. So that's happening next. And then I change that background color. So the second aspect of the graphic that I want to change is its location. So to change the location, I access the sim text graphics shape property. Here, I am changing its location by calling the geometry engine's move method, and I'm providing a new destination point for each text label. So finally, I want to apply these 2 changes back to my graphic element. So I call the set graphic method on the graphic element, and I pass in my modified graphic. So now let us look at this change back in Pro. Let me disable my breakpoints and look at the changes back in Pro. Notice now that my callout labels have a different color, so they stand out better in the background. and they've also been repositioned to the right so they don't hide any of my features. So in this demo, I showed you how you can create graphic elements, select text elements, group them, ungroup them, and even modify existing graphic elements. This brings us to the end of the graphics layer session. Let us now shift focus to the new Reports API in Pro. A report in Pro is a well-formatted multi-page representation of your data. A report contains a tabular list of attributes, summary information, or both. Using the Pro SDK, you can create reports, modify report elements, and export it as a PDF. The Report SDK functionality in ArcGIS Pro is delivered through the ArcGIS Desktop Reports namespace in the ArcGIS Desktop Layouts assembly. The report class provides access to various report elements, the properties, and methods. Reports are stored in Pro as report project items. You can see them here in the catalog pane in the screenshot on the slide. Existing reports can be opened as a report view, which is what you see over here. Using the Pro SDK, you can access a report using two patterns. You can reference a report object associated with an active report view. As seen in the code snippet over here, access the active report view using the report view's active property. From the active report view, use the report property to access the underlying report object. You can also access a report from the associated report project item located in the catalog pane. Use the report project item getReport method to return the underlying report object. To open this report object in Pro, call the createReportPane async method available on the ProAppPanes class. Here in this code snippet, I first query all the report project items in my current project using the getItems method. It is a templated type, so I'm specifying the report project item as a type. I find the specific report I'm interested in using a simple link expression. I then use the getReport method on this report project item to retrieve my report. To open the report in Pro, I'm calling the createReportPane async method and I'm passing in the report object. This opens a report in a report view and makes it active. A report object contains a main section called the Reports section. This is the highlighted red section here is the Report section. The Report section contains a collection of the following child elements: the report header, the report page header, the report details, this is where the attribute contents will be displayed, the report page footer, and the report footer. The report object can be displayed as a PDF as shown here in the screenshot. If a report is grouped on an attribute, the following two sections also exist: the report group header and the group footer. Here is an example of a grouped report. Notice how on the PDF on the right, the data for the cities is grouped by the state name. We will now see how you can access these report sections using the Pro SDK. The first task is to access the report section from the report object. In the code snippet, I'm using the report class's elements property to access the report section. I then cast it to the report section type. Next, I access the report section child elements using the elements property. Cast the retrieved elements to the section you need. Here in the code snippet, from the report section, I use the elements property to access all the child elements, and then I retrieve the report header using the off-type filter operation. The various report section elements derive from the report section element base class. Create a report programmatically using the createReport method on the report factories class. To create a report with minimum parameters, use the overload that accepts the report name and the report data source. The report data source is a class that represents the underlying data of the report. The report data source class also defines the fields in the report as well as the definition query that filters the underlying data. The code snippet here shows how to create a report. I'm creating a new report data source using the constructor. Notice the parameters are passed to the constructor. I'm passing in a sim data connection to a dataset. No definition query, so all the data will be used. I'm passing in false as a Boolean parameter so that I'm not using any selection in the current dataset. And then finally, I'm passing in a list of fields to display the report. I'm next calling the create report method on the report factory class. I'm first passing in a string for the report name and then the report data source object that I just created. There are two constructors available to create a report data source. The first constructor is shown on this slide. This constructor requires a map member. This should point either to a feature layer in the map in a project or a standalone table. The next parameter is an optional string for a definition query to filter the data. Pass an empty string if you don't need a definition query. Next, pass in a Boolean to specify if you want to use an existing selection on the map or table. Lastly, you have to pass a collection of sim report fields to include in the report. A sim report field object represents a field in the report. The name property of the sim report field is used to specify the field name. So the code snippet here illustrates this constructor clearly. I first get the feature layer to use from the map in the project. Here I construct an array of fields. I have 3 fields: state, city, and city elevation. And here I'm creating the report data source object using the constructor. I'm passing in the 4 parameters that we just discussed. The second constructor to create a report data source is very similar. It uses a sim data connection to specify the underlying data. So this allows you to connect to a feature class in a file GDB or enterprise data. In the code snippet in this slide, I'm creating a sim data connection here pointing to a feature class in a local file GDB. I then define the fields just like we did before. I then call the report data source constructor to create the object. I'm passing in the sim data connection and then the definition query, the selection data set, if I want to use that specified by this Boolean parameter, and finally I'm passing in the list of fields that I just defined. Field values displayed in the report can be sorted. This allows you to organize the data in a numerical or an alphabetical order. Use the sim report fields sort info and sort order properties to configure sorting information. The collection of fields with the sorting information is passed either to the report data source when it is being created, or it can be applied to an existing report using the set data source fields method. So here's the code snippet. Here's a list of fields that I want to include in the report. Notice that I first want to sort my state name field. So I specify the sort order to be 0. I want to sort the state names alphabetically. So I'm specifying the sort info property to have an ascending sorting. And then I want to sort within each state. I want to sort the city names alphabetically. So now I specify the sort order to be 1 and again sort info to be ascending. So using this collection of sim report fields, I am creating my report data source object. I'm passing in the list of fields with the sort info included as a parameter. And optionally, you can also, for an existing report, you can pass the list of fields to the set data source fields as a parameter. Report data can be grouped on a common repeating value. Grouping is specified using the sim report fields group property. Like sorting, grouping is specified by providing a list of fields with the grouping info. You specify this list of fields either to the report data source constructor, or you can use a set data source fields method on an existing report and pass in the list of fields. The code snippet here on this slide shows this. Notice that the sim report fields defined here, I specified the group property to be true for the state field. Then I pass in this list to the report data source constructor just like we did before. Or I can pass this collection of fields to the set data source fields method in the existing reports. Okay, now on to a demo to see all these new report API methods that we just discussed. I have a Pro project open over here. Notice in the catalog pane, I have 5 report project items. For this demo, I've created a custom tab over here with a collection of 3 buttons. I'm going to first show you how you can access these report project items and open them. You can click this Open Report button and look at the breakpoint in Visual Studio. So the first thing I'm doing is I'm retrieving the collection of report project items in my current project. I'm using the getItems method and I'm passing in the templated type to be report project item. This returns a collection of report project items in my current project. As we saw, I had 5 report project items. So in IntelliSense, you can see that these are the 5 items that have been retrieved. Next, I'm going to select one of the report project items and then I'm going to call the getReport method to retrieve the underlying report object. I also want to open this report, so I call the create report pane async method and I pass in the report object. And in Pro, here is my report object that has been displayed, USA States Report. Okay, so now that we have this report open and it's the active view, let us look at the various sections in the report. So back to my custom tab, I've created a button palette here and I'm going to use this to retrieve the various report sections. So as you can see, this report has the main report object and 5 child elements. So first, I'm going to retrieve the main report section. I'm going to click on this button in the palette and here is the code behind in Visual Studio. So the first thing I'm doing here is I'm accessing the report view class's active property to retrieve the active report view. Next, I call the report property on the active report view to retrieve the underlying report object. So now that I have the report object, I'm going to use the elements property and query for the report section. I use the of type filter and cast the returned object to the report section type. So this gives me the report section type that I'm looking for. And then for the purpose of this demo, I'm going to highlight this section. Here is my report section highlighted with a red rectangle. So similarly, from within the report main section, let us access the report details. So I'm going to access this button in the palette. Again, I access the active report view. I get the underlying report object. And first, I access the report section because I have to start with that. And then I call the elements property on the report section. And here I'm interested in the report details. So I filter using the of type method and filter for the report details. So again, for the purpose of this demo, here is my report details section highlighted in red. The report details section contains my field attributes. So let us look at those fields. So here is my report fields. And as you can see, I've highlighted the 3 report fields in this details section. So the last demo I'm going to show you is how to programmatically create a report. So I'm going to click this Create Report button. The first thing I'm going to do is set up my report data source object. For my report data source is going to use the US cities feature layer in one of the map project items. So the first thing I'm doing here is I'm retrieving the map project item, and from within this map project item, I am retrieving the US cities feature layer. So this will be the map member that I use in my report data source. Next, I am creating a list of sim report fields using the constructor. Each of the objects in my sim report field collection will represent a field in my map member, in my US cities dataset, and it will be displayed in my report. So here I am specifying the state name field. I want to group on the state name field, so I set the group property to true. I also first want to sort on the report name, on the state name, so I specify the sort order as 0, and then I specify the sort information to be ascending. I also want to alphabetize the cities within each state, so I specify sort order for the city field to be 1 and the sort info to be ascending again. So now that I have these pieces of information, I'm ready to create my report data source using the constructor. I pass in the map member, which is a US cities feature layer that I have retrieved. I do not want to use a definition query, so I pass an empty string. I do not want to use a current selection set, so I'm passing false. And finally, I'm passing in the list of sim report fields that I configured. Using this report data source, I'm now calling the create report method on the report factory class. I'm passing a string name for the name of the report and my report data source object. This will return a report object, and here I open the report using the create report pane async method, and I pass in the report. So now let us look at that in Pro. So here is my first report that I just created programmatically. Notice that it is grouped on the state name, and the fields are the city and the city elevation. And let us view the report as PDF format. So to save time, I've already exported it, and here is my PDF version of the report. You can see that it's grouped on state name, and the fields are city and city elevation. The city is city names are alphabetized, and here are all the other states. Now let's go back to the slides to learn about how you can modify existing reports and export it. Thank you. Existing reports can be modified in the following 2 ways. To create new elements on an existing report, use the methods available in the report element factory class. The elements that can be added to a report are new fields, statistics, text elements, picture graphic elements, charts, and attachments. You can change the underlying data source of an existing report using the set data source method. The set data source method requires a report data source object as a parameter. Change the underlying data source of an existing report for any number of reasons: broken links, change the definition query, etc. The important thing to note here is that the schema of the data sources need to be the same. New elements can be added to an existing report using the various available methods in the report element factory class. I have listed these methods in the table in this slide as a reference. When you create an element using any of the methods listed in the table in the previous slide, the added code must provide the following 3 items as the parameter: an element container identifying a report section within which the element will be created. For example, to add a new field, provide the report details section. Provide an envelope parameter to help place the element location. Finally, provide additional parameters required for the specific element. For example, a sim report field is required parameter to add a new field to an existing report. In all these cases, a new graphic element will be returned. Here is a code snippet that adds a field element to an existing report. I'll be doing this in the demo coming up, but let's review the steps in this snippet. I'm first going to create a new sim report field object specifying the field I want to add. In this case, I'm going to add the population 1990 field to my report. Next, I retrieve the report details section. This is the container where the field will be placed. Notice how I first retrieve the report main section, and then I retrieve the report details child section from it using the elements property. This is the element container that will hold the new element. Next, I'm specifying the location to place my field using this envelope object I create. Final step, I call the create field value text element method on the report element factory class. I'm passing in the report details section, the envelope of the new field, and the sim report field as the parameters. This will return a new graphic element object and will create a new field on my report. There are two main scenarios when you might want to change the underlying data source for a report. If a report's underlying data source has been moved or renamed, the connection to the layer is broken. Alternatively, you have an existing report that has been designed specifically for your business needs. You can modify this specialized report to use data from the feature layer using a new definition query without recreating additional reports from scratch. For example, in the demo coming up, I will show you how you can use the same report object and generate county-wide tabular data for different states. To change a report's underlying data source, use the setDataSource method on the report object. This method requires a report data source object as the parameter. The new report data source can be created using the constructor. As you may recall, there are two flavors available. You can use a map member or a sim data connection. Here's a code snippet for this. I'm first constructing my new report data source object. I specify the feature layer I want to use. This might be the same or different to the one in the existing report, but the schema must be the same. I then specify the fields in the report. Again, the schema and the fields must be the same. Notice in the constructor for the report data source, I'm passing in the feature layer. Here I'm passing in the definition query. State is equal to Alabama. I then pass in the other parameters such as the Boolean for the using this current selection set. I'm specifying that as false and the list of fields. I pass this report data source object as a parameter to the setDataSource method on the report underlying report. A report can be exported to a PDF format using the export to PDF method on the report object. This method requires 4 parameters: the name of the output PDF, a PDF format object to specify the options for the generated PDF, report export options to define export options such as page numbering, and a Boolean parameter specifying whether to use the current selected set of features. The code snippet here illustrates this. I first create the PDF format object. I specify the resolution and the file name. I then specify the report export options here, such as the pages to export, the total page number override, and the starting page number label offset. I will use the current selected set of features, so I'm setting a bool property here to be true. I pass all these parameters to the export to PDF method. We will see this in the demo coming up. In this demo, I'm going to show you how to add a new field to an existing report, how to export to a PDF. I will also demonstrate how to repurpose an existing report, change its underlying definition query, and generate various PDF views of the same report object. This is the same Pro project that I used in the first reports demo. The report view that you see here was created programmatically in the first demo. It lists the cities in each state and the elevation. The report is grouped on the state name. To save time, I have applied a definition query to this report. I'm filtering for the state of Delaware. The data set has more than 3,000 cities, so this saves time by using a smaller data set. Now I want to add a new field to this report that we've created. The data set also has a population info, and I want to add a new population field to each city. Here in the report demo 2 tab, I have an add field button over here, and I'm going to step through the code. Here is the breakpoint in Visual Studio. I get the underlying report object from the active report view. Here I create a new sim report field object using the constructor, and I set the name property to population, which is a new field that I want to add to my existing report, and I set the field order to 2. From the main report object, I access the report section element. As you may recall, the report section element contains the report details, and report details is where the fields are located. So I use the elements property on the report section and access the report details section. Here I create an envelope that will define the location of my new field on the report view. I use the create envelope method on the envelope builder class, and I pass in 2 map points, the lower left point and the upper right point. This returns an envelope that I store in this new field envelope variable. This will define the exact location of where I want to place my field. I call the create field value text element method on the report element factory class, and I pass in the 3 required parameters. I pass in the report details section where the field will be located, an envelope parameter that will define the actual location of the field in the report view, and the new report field that I want to create, which is the population field. I also need to add a new field title for my population field. The field title is located in the report group header. So I access the report group header child element of the report section. Next, I create an envelope to define the location of the field title. I again use the create envelope method on the envelope builder, and I pass in the 2 points, the lower left and the upper right. In the last step, I call the create rectangle paragraph graphic element method on the report element factory and pass the 3 parameters that it needs: the report group header where the field title will be located, the new envelope, the new field envelope variable that will define the physical location of the title on the report view, and the name of the new field, which is population. So I'm going to hit continue to see the result in Pro. Notice that the population field title and the population field has been added to my existing report. So let us view that in PDF. So on the ribbon, I'm going to click the export button. Let's step into the code. I access the report from the active report view. I create a PDF format object using the constructor. I set the resolution of the PDF to be 300 dpi. And here I set the output file name to the full path of where I want to create my PDF file, including the file name. Next, I create the report export options object using the constructor. And here I specify the pages that I want to export using the export page option. There are also other properties that I could use, things like the total page number override and the starting page number label offset properties. I set this Boolean variable to be false, specifying that I'm not going to be using a selection set. Now, using all these properties, I export my report. The export to PDF method is called on the report object. I pass in the name of the report, the PDF format object, export options, and the use selection Boolean. This will create a report in PDF format, and I'm going to use the system default to view it using the start command. So let us look at the output. Here is my first report PDF with the table grouped on the state name, the city, elevation, and population fields. Notice how the cities are alphabetized. I did that when I created the original report in the first demo. Okay, so now back to Pro to show you my last workflow. Okay, so here I have the Vermont State County Population Report. I've created this with many design aspects specific for my organization's requirements. The report has 2 components. It has a report with a supplemental page. Notice that the data source is set to the US counties layer, and I'm also filtering it using a definition query, state is equal to Vermont. In the report, I have a chart showing the population of Vermont in 2000 and 2019. And here is a tabular data with the population information and some summary statistics information. Here is a layout supplemental page. This is pointing to a Vermont county map, which is a layout in my project that you can see here. So this page is included in my report as a supplemental page. And to give you an idea of how the PDF of this report looks, I have created the PDF format with the chart, the table, and the map of the Vermont counties. Notice some of the text elements here are customized with the state name, the Vermont County population change, and some Vermont population totals. Okay. So now I'm tasked with creating similar reports for other states. I want to show you how I can use this existing Vermont report and generate multiple reports for different states without duplicating the report object and all the work that went into creating this report. So on the ribbon here, I have a button palette with 3 buttons: Delaware, Rhode Island, and Connecticut. These buttons can be used to generate county reports for each state using this existing Vermont report object. I'm first going to show you how to do this using the Delaware button. I click the button to step through the code in Visual Studio. I first get the underlying report object from the active report view. I first want to create my new data source for the Delaware report. So first I get the map that contains my US county layers. I get the map project item, and then I retrieve the feature layer. Next, I create a collection of SIM report fields. Each of the SIM report field in this collection is an existing field in the data set, and it is the same collection that is in the Vermont report. Using the constructor, I create a new report data source object. I pass in the feature layer, and then I pass in the definition query, state is equal to Delaware. This is the point where the magic happens, where I swizzle the Vermont report with the Delaware data. I then pass in false for the Boolean parameter. I don't want to use a selection set. And the last parameter is a list of SIM report fields. I call the set data source method on the report object, and I pass in the report data source that I just created with the definition query set to Delaware. This will automatically update the chart at the top of the report and the tabular data. Along with the data, I also have to change a couple of text elements. I have to change the titles to say Delaware instead of Vermont. I do that here in the next couple of steps. I first get the specific graphic text elements, and then I use the set graphic method to change the title to list Delaware. Now I'm going to get the layout project item that contains my Delaware county map, and then I access the report layout page section, which is the supplemental layout page in my report object. Here in this step, I call the replace layout page method on the report object, and I pass in the layout item that I'm going to use, which is the Delaware layout, and the name of the report section where this layout will be included. And here is the last step. I change the report name to be Delaware. Okay, so let us look at the report. So notice here that the definition query is now set to Delaware. My supplemental page is pointing to the Delaware layout. So let us look at this PDF, look at this report in the PDF format. I have a view report button that I've created that will export this Delaware report to PDF format and display it right inside Pro. So So let us do that now. So here is the Delaware County population report, and the chart has been updated with the counties in Delaware. So is the tabular information. Notice that the titles have been swizzled to have the correct state name, and the supplemental page includes the Delaware County layout map. Similarly, I can generate this report for other states. I'm going to click the Rhode Island button and view the report for Rhode Island. So notice that the report's definition query has been updated to Rhode Island, and the supplemental page has also changed over here. And let us look at the output PDF. Here is my PDF view of my Rhode Island County population report. The chart here has been updated, and so is the tabular data and the layout. So this workflow shows how you can repurpose one report object with multiple design elements for your workflow and generate additional reports and PDFs by making modifications to it in the underlying data source. This brings us to the end of the session, and I want to mention one more thing. All the data and the code that I've used in this session are available in GitHub. The QR code here will give you access to this data, the PowerPoint, and the code. Thank you.